My home wishes to everyone. Myself G. Chandana. I am graduating from Srinivas Ramanujan Institute of Technology, holding a roll number 234080425, and I am from EC department. Today, my topic in this presentation is about infinite transmission lines from the subject EM waves and transmission lines. So, my topic is infinite transmission line in the theory and analysis. So, introduction to infinite transmission line. See, these transmission lines are nothing but transmitting the electricity from one place to another. So, the infinite transmission lines are theoretical constructs. These are used to simplify circuit analysis. So, they extend indefinitely in both the directions, allowing from consumption of uniform characteristics. This concept is essential in understanding the wave propagation and the impedance matching in radio frequency application. Now, before going to the infinite transmission line, now let us discuss about the basic concepts of these transmission lines. So, the transmission line is nothing but the specialized cable or other structure that carries electrical energy from one place to another. So they have the key parameters which include a characteristic impedance, propagation constant, and also the wave velocity. So the behavior of these transmission lines can be analyzed using the differential equations and the phasor representation. So what are the characteristics of infinite transmission line? So an infinite transmission line is characterized by constant parameters such as impedance and the capacitance. So its infinite length results in reflection being negligible, simplifying analysis. So the input and output properties are uniform across the length of transmission lines. So the wave propagation in infinite transmission line. So let us see how the wave propagation will be in the infinite transmission line. So in an infinite transmission line, electromagnetic waves propagate without reflection. So in the infinite transmission line, there will be the electromagnetic waves, so they does not have the reflection. So the wave equation describes how voltage and the carry current varies along a line. So here you can see the first wave is voltage voltage wave, and the second one is current wave. You can see how voltage and the current vary along the line. So the phase velocity of the wave depends on the line's inductance and the conductance per unit length. And the next one is impedance and reflection coefficients. So the characteristic impedance of an infinite transmission line is defined by its conductance and the capacitance. The coefficient become negligible as the length of the line increases. So this leads to an effective transmission of power without the significant loss. So what are the applications of these infinite transmission lines? So the infinite transmission lines are used in radio frequency and microwave engineering. They help in designing filters, amplifiers, and antennas by simplifying complex calculations. So their theoretical framework assists in impedance matching techniques for optical power transmissions. So here you can see some of the applications of electronic devices of these infinite transmission lines. So what are the limitations of this infinite transmission line model? While useful, the infinite transmission line model is an idealization and does not account for real world losses. So these infinite transmission lines are just for idealization and they are not practically applicable for the real world. So practical transmission lines are finite length leading to reflection and the standing waves. So the engineers must consider these factors when applying the model to real world scenario. So these are used for idealization and it is not used for real application. So the engineers must consider these all factors to apply this in the real world scenario. So case studies and examples. Numerous case studies demonstrate the applications of infinite transmission line in uh, circuit design. Examples include analysis of transmission losses and the efficiency in long distance communication lines. These case studies highlight the importance of the infinite model in theoretical and also in the practical designs. So the conclusion of this infinite transmission line. So the infinite transmission line model is a fundamental concept in electrical engineering. So this concept is very important in the electrical engineering. So it provides a critical insight into the wave propagation. So it gives how the wave propagates, so how the current and the voltage is varied, and also the impedance matching and circuit analysis. So from this infinite line, we can understand the theory is essential for advancement for model communication techniques. So these are the conclusion of this infinite transmission. So thank you for watching this presentation. Thank you.